Good morning, Tahmina Khan is here in TKMaths S1. In today's video, which is video number 4 on the series of sampling and estimation. In this video, we will study central limit theorem, and I will show you the assessment 3 question for the sample mean, which was our video number 3 and 2. So I want you to try out how much you understood, and then you can write a comment to me for further clarification. So these are the 3 QR codes. For all my videos I have made on P3. This one is for P3. This one is for M1. And this one is for S2. So you can reach this and you will find more videos here. So here is the assessment for sampling mean. Last videos we studied this. So now you can try out, and I have answers here, not the method. So you can verify your answers. And for detailed explanation, you can write in the comment. I would explain if you don't get this, but I'm sure you will understand this. So let's start today's lesson, which is on central limit theorem. What is central limit theorem and why do we need it? This is, by the way, S2. Okay, so sampling and estimation is the topic of the A-level mathematics S2. Code is 9709. So what does this say? It says that if the sample size is taken from non-normal population, very important thing. So sample has been taken from a population which is not normal, right? And with mean mu and variance sigma square. Now the sample tends to a normal distribution as n tends to infinity. What does this mean? If sample size is large, say n is greater than equals to 30, then you can apply normal distribution on it because it will be approximately normal. So we will calculate the probability with the help of the normal distribution method. So let's see here. Now we have seen in the previous video that the sample mean distribution is mu and sigma square over n. We have seen that. Now central limit theorem is saying if n is large, that is greater than equals to 30, then we will use this distribution to calculate the probability, right? So it is the same thing stated here again. So let's go to the example. So over a long period of time, it is found that the amount of sunshine on any day in a particular town in Spain has mean 6.7 and a standard deviation 3.1 hours. Now it is not saying it is a normal distribution, the population is normally distributed. No, it's not mentioned here, right? So part number 1 is saying find the probability that the mean amount of sunshine over a random sample of 300, which is much higher than, what was it? 30. So n is greater than 30, it's 300, which is greater than 30, right? So I can apply CLT, central limit theorem. So my distribution will be what? Distribution for the sample size will become what? It will become 6.7 and it will become 3.1 square over 300, right? This is what we have studied. So it will become this. Find the probability for sunshine between 6.5 and 6.8 hour. So what is the question? Question is saying that you have to find out the probability for 6.5 hour to 6.8 hour. This is the question. So now we know what we will do. Since n is large enough, we can apply CLT and calculate the probability. So Z is equals to, now what is Z? So I will apply this and try to solve it. So let's see here. I'm doing slowly. If you want to put the video on pause and want to try out yourself, you can. Okay. So now it will be 6.5 minus 6.7 over 3.1 root 300. You can pick up the calculator. And the 6.8 minus 6.7, 3.1 root 300. Okay. So now Z will be between which two values? Let me take the calculator. Minus 1.117. I hope no calculation mistake will happen. 0.559. You know, when we are writing z value, we have to write up till 3 decimal places. The reason is the table we study is given up till 3 decimal places, right? So what does this mean? If I write or show you the visual of it with the help of the diagram, it will be better. So positive z is here 0.559 and negative z is here minus 1.117. So I have to calculate this probability. So what we will do? We will do this whole probability from here minus this one. Agreed? So I will write probability of z less than 0.559 minus probability of z less than minus 1.117, right? So this whole thing minus this part. And we know negative z value is not given in the table. So what do we do here? We use the concept of symmetry. 1 minus probability of z less than 1.117. I hope you remember this, because at this point the expectation is that you have the prerequisite knowledge of the normal distribution calculation, right? Otherwise you can watch my videos of S1. The QR code I have shared, you can go there and you will find for S1 also. Okay, so now I will use the table and write down the z values. So again 0.559, the z value is okay, so it is 0. Let me change the color now. It is 0. I hope no mistake will happen in reading the values. It is 0.7119 minus against 1.117, it is 0.8679. Okay, so now you can use calculator and the answer is coming 0.5798. Now this is your probability. So now final answer you can write in 3 significant figures. So what it will become? 0.580. Right? Z values we always write in 3 decimal place because we have to calculate the probability from there. So this is first part of the question, which says find the probability between the R 6.5 to 6.8. So we have calculated. Now part 2 is saying give a reason. So it's an explanatory question. Give a reason why it is not necessary to assume that daily amount of sunshine is normally distributed. So why we do not need to assume it in order to carry out the calculation of part 1. So very simple answer. Why it is not necessary? The reason is because the n size is very large. So you can write here, rather than I write, you can write here, it is not, I'm just writing because some people like it, or I'm explaining, you can see it is not necessary to assume. So you can pick up from here the question. It is not necessary to assume that the daily amount of sunshine is normally distributed in order to carry out this, because the sample size n is very large, that is 300. And according to the CLT, which states that for large n, the distribution of x is approximately normal. So if I type here, for example, for some people, if it is not easy to remember what I'm saying, so let me explain here. Okay, so I hope you understood. Thank God I recalled this thing. So this is question. Now the next question is for your test for your own understanding. So you can put the video on pause. I have solved the question here for you, but you try it out yourself first, okay? So more or less the same type of question. So I hope you have put the video on pause. I'm showing you the solution, which you will see after solving the question. So next video will be on more question of central limit theorem. So I will end this video here. I hope you understood. If you have any question, you can ask it in the comments. So please like the button and press press like and subscribe button and share it with your friends. Take care. Allah Hafiz.